All right, we are ready for our next lesson. So this is lesson 7 in unit 3. It is on solving nonlinear systems. So make sure you update your table of contents. For me, I will be on page 59 of my uh, notebook. So here's just a picture of me. Alrighty, so for your learning targets, it is I can solve systems of nonlinear equations by substitution and or, so either one is fine or both, by graphing. So here are different types of nonlinear systems plus solutions. Just want to let you guys know that when we are referring nonlinear, we're just referring to one of the equations being either it could be a quadratic, it could be a cubic, it could be anything that is not a line. So here are some examples. We can have a quadratic equation and a line. So you will have 3 different cases. So this is your parabola, that's your line, that's your parabola, that's line. And then you can ask yourself, in the first case, how many solutions do you think you're gonna have? Case number 2, case number 3. As you can see in the first case, the parabola and the lines do not intersect, and as a result, there is no solution there. And over here, they intersect at one point, so we have one solution. And for the last case, the line and the parabola intersect twice, so we have 2 solutions. When we are in solving nonlinear systems, it's okay for you to just put no solution. You do not need to say 2 imaginary solutions. And then we can also have 2 parabolas. For the example I'm giving you, one opens up and the other one opens down. So we have one up, one down, and then you have same thing. You can ask yourself, how many solutions do each of the cases have? For the first case, since the parabolas do not intersect, there's no solution. Over here, they intersect at one point, so we have one solution. And over here, they intersect twice, so you also have 2 solutions here. So you can pause the video if you need to copy it. So now we're gonna go over some examples. So for example 1, we're gonna solve by graphing, and then we're gonna solve by substitution. So you have 2 equations here. One of them is a parabola, the other one is a line. So let me give you a coordinate plane. So you can pause the video and graph both of the functions. So I'm going to go over it now. So we're going to graph each equation, and we're going to find the point of intersection. So for the first one, you have y is equal to x squared minus 2x minus 1. Remember, when we're graphing in standard form, we use x equals negative b over 2a to find our axis of symmetry. So this is AOS. Remember, this is the first lesson we did in Unit 3, which is graphing standard form. So this is negative of negative 2 over 2 times 1, which is 1. So you have your axis of symmetry at 1. So let me do that. And after that, we could do a table to find our vertex and our other points. So x. So start at 1. And then you substitute 1 in here. That's 1 minus 2, which is negative 1. Negative 1 minus 1 is negative 2. So your vertex is 1 comma negative 2. 1 comma negative 2 is right here. And we can use our shortcut to find the second and third point. Your A is 1. So we could go from here, 1 up, 1 to the right, 1 to the one to the right, 1 to the left. So right, left. And then let's pick another point. So maybe I'll pick 3. So 3, you substitute that in, that's 3 squared minus 2 times 3 minus 1. That's 9 minus 6 minus 1, which means your point is at 3, 2. So 3, 2, which means 2 units to the left, I also have the same thing. So let me graph that. Okay, my parabola is a little off the chart, but you get it. It's supposed to be right here. I'll move my parabola later. All right, and this is a line, so let's graph the line. So we would start by our b is -1. Your slope is -2, so let's make that as -2 over 1. So 2 down, 1 to the right, 2 up, 1 to the left, 2 up, 1 to the left, 2 up, 1 to the left. So you can go ahead and graph that. So then now ask yourself, where do they meet? Where do the parabola and the line meet? And they meet right here, and this point is 0, -1. So this implies our solution in this case is 0, -1. And you can also check your work by substituting 0, 1 into both equations to see if 0, -1 satisfies both equations. So we'll just try it really fast. You substitute 0, you substitute -1, and the statement is true. So you can conclude that the solution is 0, -1. And now I'm going to solve by substitution. So for substitution, you already have y is equal to something, y is equal to something. So for substitution, we can just put them equal to each other. So this implies we have x squared minus 2x, that's the first equation on the top. Equation 1 is equal to -2x minus 1. So to solve, we can just move everything to one side. Add 2x, add 1, we add 2x, we add 1. So that cancels, we get 0 on the right hand side, and then over here on the left hand side, there's only x squared left. So to solve for x, we can just square root both sides, square root both sides. Remember when the discriminant is 0, we have one solution. So over here, you do not need the absolute value. You could just put x is equal to 0. Look, we also get x equal to 0 over here. And to find the y value, you can substitute 0 into either one of the equations here. I personally think equation 2 is easier, so I'll do y is equal to -2. So I'm using equation 2 right here. -2 times 0 minus 1. So my y is equal to -1. So our answer using substitution is also 0, -1. So now that we're using both methods, which method do you prefer? Do you prefer graphing or do you prefer substitution? In my opinion, I think substitution is more direct. It'll be faster, but that's just my opinion. So as a result, for question 2 and on, I'm going to solve using substitution. You can pause the video if you need more time. And now I'm going to move on to question 2. Oh, so here is an example of how my notes look like. So question 2, you're going to solve by either graphing or substitution. You can pause the video and try. Okay, so for my case, I'm going to try solving by substitution. So for solving by substitution, I will have, once again, I already have y is equal to. So I have x squared minus ax plus 12 is equal to 4x minus 24. And also, I would not want to graph in this case because did you see that my b for equation 2, my y-intercept is negative 24. That might be a little too big for me. Anyhow, let's continue solving using substitution. So I will make this into standard form. So I'm gonna subtract 4x, gonna add 24, subtract 4x, add 24. So we get x squared minus 12x plus 36 equal to 0. Once you guys get here, you can solve either using factoring if it works. You can use completing the square, or you can use the quadratic formula. For me, since we just learned the quadratic formula, I'm going to use the quadratic formula. So here my a is 1, my b is negative 12, my c is positive 36. So once again, you do not need to use the quadratic formula. You could just use other methods. So over here, using the quadratic formula, I have x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. So then we substitute your ABC. So this is negative 12, 136, and my a is 1. So to simplify, I get negative of negative 12, which is positive 12, plus or minus square root of negative 12 squared is 144. And then you have negative minus 4 times 1 times positive 36 is negative minus 144 over 2. So x is equal to 12 plus or minus square root of 0. Just want to let you know square root of 0 is just 0. So remember, anytime your discriminant is 0, we only have one solution. So you have 12 over 2. 12 over 2 is 6. When you find x equal to 6, you're not done yet because we still have to find y. So to find y, I'm going to use equation 2 because it seems easier. So y is equal to 4 times 6 minus 24. And you're going to see that y is equal to 0. So our solution in this case is 6, 0. In my notes, I actually graph both lines as well, but I could show you at a different time, but I don't have it in my PowerPoint. Okay, moving on. For number 3, so from now on, we're just gonna solve by substitution. You can pause the video and try it yourself. Okay, now I'm gonna go over it. So for step 1, we're gonna solve equation 2 because look at both equations. You have like none of the variable is equal to something. So we're gonna solve x plus 4 equal to x plus y equal to 4. So over here, I'm gonna solve for y. So you would subtract x to both sides. When you subtract x, this is what you get. Y is equal to negative 4, negative x plus 4. And then step 2, we're going to substitute negative x plus 4 into equation 1 to solve for x. So your y is right here. So I'm going to substitute that right here. So instead of putting y in the next step, you're going to use a big parenthesis and substitute negative x plus 4. So it looks like this. After that, make sure you distribute. my PowerPoint is not showing correctly, but you can just pretend you didn't see the check here and the solution. So after you distribute x minus negative x is positive x. So you get x squared plus 2x minus 4 equal to negative 1. And then after I get here, you know what I'm going to do? You know what? I'll just rewrite it. X squared plus 2x minus 4 is equal to negative 1. When I get here, I am going to solve using completing the square. Once again, you do whichever method you like. I just want to show you different methods. So that is x squared plus 2x is equal to 3. Now we're going to add a number to both sides to complete the square. And this number will be half of my b. 2 over 2 is 1. 1 squared is 1. So now I'm going to rewrite the left-hand side as a perfect binomial. I get x plus 2 over 2 is 1. So 1. And also don't forget 1 squared is 1. And then on the right-hand side, I get 4. And then we square root both sides, square root both sides, square root, and the square cancels. And let me finish my work here. I have absolute value of x plus 1 is equal to 2. Take out the absolute value. We get plus or minus 2. And then you subtract 1 to both sides, you get negative 1 plus or minus 2. Be sure to separate that into two cases, negative 1 plus 2, negative 1 minus 2. So the top one, you get positive 1, you get negative 3. You get 2 x's. We still have to substitute both x's to find your y. You can find your y using the original equations, or you can use the equation you found in step 1. So let me show my work here. I'm going to use this equation right here. So y is equal to negative x plus 4. Y is equal to negative x plus 4. So my first x is 1. So this implies I will get a point at 1, 3. Because look, negative 1 plus 4. And then the second one is negative 3. So I have another point of intersection at negative 3, not 4, 7. So these two are my answers. So that implies if I were to graph both of the two functions, my graphs would intersect at 1, 3 and negative 3, 7. So from a graphical approach, so you see at this point, that point will be negative 3, 7, and this point is 1, 3. And when you guys are in pre-calculus or calculus, you will learn how to use TI-83 and up. I'm referring to graphing calculators to graph these, and your teachers will show you how to find the point of intersections. So that's number 3. Let's try number 4. For number 4, we're doing exactly the same thing. I probably want to solve for y using equation 1. So step 1, I'm going to solve for this. So I'm going to solve for y, so I will subtract x squared, subtract 2x, subtract x squared, subtract 2x. So that cancels. So step 1, I will get y is equal to negative x squared minus 2x. Step 2, we are going to substitute whatever you get in step 1 into equation 1. So I will get 2x squared minus 5x minus whatever y you get equals negative 2. So I'm going to substitute this in here. Negative x squared minus 2x. And then after that we distribute. So we get 2x squared minus 5x plus x squared plus 2x equals negative 2. So I get 3x squared minus, combined like term, that would be 3x. You know what I'm going to do? I'm going to move the negative 2 over. So I'm going to have plus 2 is equal to 0. After that, I'm going to use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you guys can go ahead and substitute the values. That's negative 3, negative 3, that's 3, 2, 3. So x is equal to positive 3 plus or minus square root of, so negative 3 quantity squared is 9. 9 minus 12 times 2, which is 24. 9 minus 24 is negative 15 over 6. So as you guys can see, there is a negative inside the square root. So remember in the previous lessons we would say, okay, there are two imaginary solutions. But since we are dealing with systems of nonlinear equations, we can just conclude that there are no solutions in this case. And from a graphical approach, when you graph both of the parabolas, as you can see here, they do not intersect. I'm going to show you the same problem, number 4, but I'm going to show you using elimination, but you don't need to do that. I just want to show you really fast. So here we're going to solve using elimination. So we're just going to add the, make sure your x squares, your x, your y are aligned. So now we're going to add the equation to eliminate. So we're going to add them. As you can see, the negative y and the y cancels. And you get 3x squared minus 3x is equal to negative 2. I'm going to move the negative 2 to make it into standard form. After that, we use the quadratic formula. As you can see, this is still negative. And because it's negative, there are no real solutions. So you could just say the original system has no real solution, and you are done.